Jim, I want to say that we've known each other for about 10 years at this point through
Yes.
different trade groups, the Laboratory Products Association, and then the Independent Laboratory Distributors Association. I was hoping you could talk about what the LPA is doing with the student engagement.
Sure, sure. And David, good to see you. And you're right, it is 10 years. Networking is so important. Look at the relationships you build through it. What's interesting, we have a really compelling new committee at the LPA. So that's the Laboratory Products Association. And we call it the Student Engagement Committee. And what we're doing is we're attempting to build a bridge to academia for the commercial sciences. So we are the industry of science. We're the manufacturers and distributors, where we are where everything comes from in the laboratory. And it's a really great career. It's been good to me, at least I can speak for that. And I don't think many researchers realize that there is an entire industry out there where you can combine your skill sets. So if you've got an interest in science, a background in science or STEM, and business, you can combine that and make a really solid career. And there's a lot of benefits. So if your viewers are interested in checking it out, I know that there's a landing page at the Laboratory Products Association website where they can read more about it.
What I'd really love to do today is learn more about your operation and also filtration in general and how that relates to chromatography. Jim, would you want to get
Sure.
into IW Tremont and introducing the brand to us?
Sure, sure, absolutely. Thank you. IW Tremont is a family owned company. We're celebrating our 45th year in business this year, actually. I am currently the co president of the company, along with my brother and business partner, Andy Averso. Our father, Sal Averso, was the founder of this business. The business is based on the premise of bringing value and quality to the research markets, as well as industrial QA/QC. So we're predominantly in the sample preparation, filtration, separations, extraction space. We've got some ancillary products such as plasticware and lab safety porous materials. And we own and manufacture the LabExact brand. The LabExact brand was introduced about 13 years ago, and it has become a leader in the space. We're really excited about it. And clearly, our specialty is filtration, which I hope we're going to talk a lot more about.
Absolutely. Yeah, I was hoping we could get right into how syringe filters contribute to HPLC analysis.
Sure, sure. There's a lot of steps in the workflow of sample preparation. And one of my suggestions is to optimize that workflow, but don't cut corners. There's a big difference. And when you set your workflow up for your experimentation and your analysis, it's really important to checklist the items that you're going to need and then really look at the individual function of each of the materials that you're going to be using. Really, syringe filters have a significant impact on your analysis, and many people don't even know the basics of why they're so important. So one of the most important facts that they do is particle removal. So this is the removal of microscopic particles in the sample, and at its core, at its most basic function, you're going to prevent the introduction of those particles into your analyzer. For the most part, the sample preparation method is done where you're probably working with a slightly precipitated sample in the beginning because you've probably done some pre-filtration or extraction methods. There might have been a distillation method or a concentration method. But for the most part, there still could be some particles in there. You do this removal of the particles for the protection of the instrumentation. So a buildup of particulate matter in the column, in the sensor tubes, it will affect the overall performance of the instrument and really reduce the life of the column if you're doing HPLC. And these columns are pretty expensive. And there's a residual buildup over time where your peaks may be skewed or may be rounded, and that makes your work more difficult to reproduce. One of the other factors is the reduction of back pressure in the instrument. Just like you can get a calcium buildup in a water line, you can get particulate load in the lines leading into the instrument. And that creates a back pressure effect. And that back pressure affects the flow rate, which then ultimately can affect the read of the instrument. So they're really important in the process. And as important as they are to improve the process, using the wrong ones can be detrimental to the process.
That's the sample preparation mantra, that if you don't do the preparation right, that you pay for it somewhere along the line with the actual analysis. For someone who's familiar with filtration methods in general for chromatography sample prep, how do syringe filters compare?
How do they compare? You got to really look at the basics. So there's a number of factors when you're looking at syringe filters. The membrane type is the actual filter component that's in the device. And so typically in chromatography, you're using nylon, PTFE, PVDF, or PES. And for nylon, that would be suitable for aqueous solution and organic solvents, very commonly used in general HPLC. In PTFE membranes, PTFE is resistant to aggressive solvents, acids, and bases, and it's really ideal for organic solvents. PVDF is low protein binding and suitable for biological samples. And then PES, polyether sulfone, that's low protein binding, high flow rate, and generally good for aqueous solutions. So once you've chosen your chemical compatibility and the best choice of membrane type, then you have to look at the porosity, what the actual pore size of the membrane is. And this is based on the particle that you're looking to capture. The two basics are 0.45 and 0.22 micron. Generally, 0.45 is for general HPLC, and 0.2 would be used in UHPLC, which is ultra high pressure liquid chromatography. LabExact actually has a line of membranes that are available in syringe filters that we call TruPor. We partnered with the leading supplier of high-tech materials, porous materials, by the name of Hollingsworth and Vos. And this was a long-standing, very well-funded development project where they developed a new category of membrane using nanotechnology. And what we do is we are actually able to control the pore structure with the same precision as a cast film membrane. We're able to raise the loading capacity of the membrane, but we increase the flow rate at the same time. And I hope we'll talk a little bit more about flow rates and back pressure when we get into it, but it's an important factor. And so in working with the same polymer groups, we are able to introduce this new category of product, which is just a superior membrane. And then the diameter of the device itself. So this is a relationship of the device size, which translates to the surface area of the membrane. And then that surface area contributes to the device's ability to load or sample the volume that you're working with. And so if you're working with a very small sample, you would generally want to use a small diameter membrane, and a larger sample size, of course, larger. And it's a process of finding the right category of product. So you really have some variables here, and that's what makes our product line so big. We've got over 300 SKUs to choose from, but the basics of it are membrane type, diameter, and pore structure.
I appreciate that summary, and I did note down flow rates and back pressure, so we can revisit that. But what are some of the common mistakes researchers make when using syringe filters, and how can they be avoided?
That's a good question. And anyone who's done it knows the heartache of either ruining a batch of samples or a reagent or having a potentially dangerous issue in the lab. So by far the biggest issue relates to chemical compatibility of the membrane. You wouldn't want to use certain membranes with certain concentrations of acids or solvents. And we produce a robust chemical compatibility chart, and nearly every manufacturer does, and you'll generally see them posted in the lab somewhere. That's probably the primary cause of error when doing sample preparation for analysis using syringe filters. Some of the others are a really common mistake is overpressurizing the membrane. The common technique used to employ a syringe filter is simply draw your sample up into the syringe barrel, overdraw it by 1 or 2 ml to create a bit of a vacuum meniscus in the barrel itself, tilt it upward, and then screw on your Lorlock syringe filter. And don't over tighten it, because if you over tighten it and you feel that kind of death click where it went too far, it means that you've violated the threading on the barrel and you're going to probably have a leak. So don't over tighten it. It should just be snugged, and then express out the air bubble that you probably have in the barrel. And now it's time to put it over your vial and express out your sample. Do it evenly, slow pressure, just gentle enough that you feel the pressure against your finger, your thumb, and continue with a steady flow. If you overpressurize and push too hard and you feel in just a quick release of pressure and the fluid comes out, that's called an intrusion, and you've probably burst the membrane. And anyone who's done it knows that frustration. It's easy to recover because you can draw that sample out generally into a new syringe barrel and do it again, or just set that sample aside and work with a new one. But that's your first sign that that rapid release of back pressure is just indication that you've broken through the membrane itself.
And when you mentioned back pressure earlier, was that in regards to trying to prevent clogging or bursting, things to avoid?
Sure. Yeah. So the TruPor membranes absolutely reduce the instance of intrusion through back pressure buildup. And it also helps reduce user fatigue. So anyone who stood at a bench all day pushing samples knows the hand cramp that you walk away from the lab with. So the TruPor filters reduce that back pressure significantly, but there's a more practical purpose for it too. So, in terms of safety, if you overpressurize these devices, what can sometimes happen is the barrel itself and the filter can rupture and you get a spray effect, or there is possibility of getting back spray from the Lorlock fitting. And that's why you need to use proper PPE when doing these tasks. So either put the fume hood guard down or make sure you're wearing your goggles and, of course, your gloves, and have a membrane that's produced by a trustworthy manufacturer. And lower back pressure is good in this case.
I appreciate you giving such a comprehensive summary on that. Obviously, none of us know the future, and sample preparation is constantly evolving, but where do you see the field of sample filtration evolving from here?
That's a really interesting question. The instrumentation itself is driving a lot of the need for increased quality and sample preparation. As the resolution of the instruments increases, and of course, that's driven by the need of the researchers themselves, but the resolution of the instruments increases, and that really causes us to have to respond. So we've done a number of things to keep pace with the demands. First, just an overall improvement of the materials. Our syringe barrel devices are 100% pure polypropylene, and they are in their natural color tone, which is a semi-opaque white. The reason that's important is there is some very inexpensive commodity grade syringe filter product, which still is kicking around the market a little bit. And you'll see them, they're pretty easily identifiable because they're colored. And in its most basic form, you cannot dye polypropylene, without creating an extractable issue. So these aggressive solvents, when they are introduced to the material, actually wash away some of the dye that's on the surface of the polymer. One of the other things is several years ago, we incorporated ultrasonic welding into our manufacturing process. So we are actually welding the components using ultrasonic sound waves instead of any glues or adhesives. That's important because we don't introduce any of that into your sample. And then we're developing techniques and devices that help the researcher at the bench prepare the samples prior to syringe filters. So the category of syringe filters are generally considered absolute filtration. These are membranes that have a finite pore structure and they're welded around their circumference. They're a disc and they're welded around the circumference. So you can't get bleed through or leach around in the device. So your sample has to pass through the membrane. The opposing process is generally a more coarse filtration stage. So if you have a really heavily precipitated sample, cloudy, muddy, murky, think pond water, what is generally done is that sample will be passed through a Buchner funnel with a disc filter or a cone funnel with a fluted cone filter. And you get your initial clarification in that stage, and then that resultant, that effluent, that filtrate, you take and you pass through an absolute filter like a syringe filter prior to your analysis method. What we've developed is a device called the HandyPrep. And the HandyPrep, we just introduced it at PitCom this year. And the HandyPrep is a coarse filtration device. What it does is it incorporates several layers of depth filter media in a syringe barrel. And that replaces the step of the initial filtration stage in the coarse filtration part of your sample prep. And what's really cool about it is it's also compatible with syringe filters. So you could potentially do it all in one step. And talking about pre-filtration, there's a huge category of syringe filters within our line that incorporate pre-filters in the device itself. So our forte, our expertise is glass microfiber, and we've been able to develop product where we incorporate a glass microfiber pre-filter prior to the membrane in the device. And what that does is it increases the loading capacity of the syringe filter so you can get larger samples through it. The downside to using a pre-filtered syringe filter is dead volume. So imagine you've got this porous sponge, essentially a complex matrix of fibers sitting above a membrane. It's absorbent. And so it's going to retain some of that sample that you've just pushed through. And so for years, I've been racking my brain thinking, how can I reduce the effect of dead volume in sample preparation? I know, go ahead. You can make fun of me later about this is what I sit around thinking about. But but your listeners and your viewers will definitely appreciate that. And so the HandyPrep, one of the byproducts of having the filter actually in the syringe barrel itself is the plunger compresses the stack of filtration media and squeezes out the dead volume into your sample. So there's much less sample volume lost to the process. It's a neat device.
That's awesome.
Yeah.
So, one general question I always like to ask: what did we miss? What about LabExact do you want people to know that we didn't get into?
LabExact, it's an interesting brand. We've become known for quality and value, and it really is synonymous with the highest demand products used in the lab. And that's how we do our product development and selection of new projects that we're going to get involved in is we look at the workflow in the lab and we analyze how can we better partner with academia, with industrial QA QC, and make those processes better. And so we go to the drawing board and we develop products all the time. We try to introduce at least 2 or 3 new product platforms every year. But we also partner with companies like yours in looking at where do we find the value in the next step? How do we shorten the workflow and find the value for the researcher? One of the things that we can lend is some advice as to what syringe filter type should be used with what analysis method. Gas chromatography, GC, would generally use PTFE membranes, and they're typically sufficient for 0.45 micron porosity, just because particle size is not as prevalent an issue in gas stream as it is liquid. And then in ion chromatography and mass spec, generally you'd use PES, nylon, or regenerated cellulose, RC. For PES, you've got low ion extractables, and that's generally good for aqueous solutions. Nylon is suitable for aqueous solution as well, but if you're working with proteins, make sure that you're using a low protein binding membrane, and that's where PES will generally be used, or PVDF. And then regenerated cellulose is generally, it demonstrates low extractables for IC. That's usually the preference. And a really exciting category that LabExact has is just plain glass microfiber. So again, our forte is glass microfiber. It's a depth filter. And I hope everyone listening to this goes to the lab bench and does this little experiment. But believe it or not, you can stack syringe filters. They are designed to be male female sides. So you've got a lure lock and a slip port, and one goes into the other. And many don't realize that you can build a stacked filter right at the lab bench as easy as putting two of them together. So if you use a glass microfiber filter prior to the absolute filter, the membrane filter, you can pre-filter your sample in one shot, and it works great. We offer a 1 micron and a 7/10 micron glass microfiber pre-filter. And what's really exciting about our glass is it's binderless. So there's no glues or adhesives or substances that can leach out into your sample, which makes it really clean reading, lowers the background noise, and you get a really sharp peak.
I'm glad you got into that because I had no idea that stacking was possible. So that's a great tip
Yep.
for anyone out there.
Yep. Thanks.